Hey everybody, and what I'm going to do today is I'm going to explain some of your reading yesterday that you guys did about solutions and mixtures and compounds, but I'm going to hit mainly on compounds, and when I talk about compounds, we are going to talk about compounds along with, sorry, I'm still getting used to this new pen here, molecules. Okay? Now, when you think of molecule, what do you think of? Okay? If you haven't had a lot of chemistry class, there's no telling what you might think of when it comes to molecules. But let me give you some compounds, okay, that we can also call molecules, such as, and you need to be writing these down, water. Water is a compound. Water is also a molecule. Salt. We know it, we love it, and it's really bad for us if we have too much of it. Glucose. And we know that this is from photosynthesis, and it's also used in cellular respiration to create energy. This is made in photosynthesis. And then one of the last ones that I wanted to talk to you about today, on at least on this page, is carbon dioxide. Now, all of these are compounds. They're all molecules. They are made of elements. That's right. I know some of you out there probably said that. And which means that they are pure substances. So the stuff that you drink, the stuff that you put on your French fries, you eat this when you eat a plant, and the things that you breathe out are made of elements, and these compounds are pure substances. Now, what do these pure substances look like? Okay? And what I mean by that is scientists will use certain ways to talk about things, kind of like texting, like we mentioned before we left for our e-learning time. So instead of scientists writing out water and salt, which we know salt is made of sodium and chloride, okay, and this is carbon, oxygen, and hydrogen. This is carbon and oxygen. This is hydrogen and oxygen. They use shorthand. So what they're going to say is they are going to, instead of writing out water or writing out hydrogen and oxygen, they are going to write out this: hydrogen, oxygen, but this is not just hydrogen and oxygen, it's actually two hydrogen atoms bonded together chemically with one oxygen atom. Now, I know you're saying, Mr. Broom, where's the one? Well, there is no one when it comes to this. This is only something that is understood to be a one. Just like in math, if you were to write 4 to the first power, that is the same thing as 4. So there is no need to put a 1 here for exponents. There's no need to put a 1 here for a molecule or a compound. Okay? Let's think about salt. I know some of you are already on top of this. You know that salt has sodium in it. How many? Well, I can tell you it's 1. So do we write a number? And the answer is no, we do not write a number. However, salt also has more than just an element of sodium. It also has an atom of chlorine in it. So salt is a compound. And now think about compound, and you think about a compound word like anywhere. And I'm going to tell you that there's probably going to be some skips in this video. I don't mean your science teacher. I mean that my program shuts off every 5 minutes. So about every 5 minutes there might be a little bit of a hiccup in the video, and that's okay. Just keep on watching. Okay, so I said think of compound words like anywhere, sometime, and homeroom is a compound word. So that would be two things put together. Well, think of the same thing when it comes to elements or compounds with chemistry. Two or more elements put together. Can it be three elements? And the answer is yes. And we're going to see that right now. Glucose has carbon, hydrogen, and oxygen. But the cool thing about this is it's more than just one and it's more than just two. This is C6H12O6. And this, folks, is the chemical formula or the molecule, the way it looks, the way that scientists write it, for glucose. Okay, carbon dioxide. Any of y'all remember that? We know it's got carbon. We know it's got oxygen. Let me do something real quick. I wrote that a little too... There we go. It is actually CO2. So, now, how many atoms of carbon do we have here? Well, we only have one. You said there's no number. That's right. We only have one. Just like one atom of oxygen here, one atom of sodium here, one atom of chlorine here. Now, if we were to draw all these, and I'm going to draw it for you in just a second. If we were to draw all these, okay, if we were to draw water, whoops, magic here. Get rid of that. If I were to draw water, H2O, this is the way I would draw it. Okay, this circle is going to represent one atom. Okay, and then I am going to do a different color here. And going back to blue, I'm going to make this a little bit easier for me. Okay, so right here on this, I have two atoms of hydrogen. Hydrogen is going to equal blue. And I'm going to have, I need to make that a little bit skinnier, and I'm going to have one atom of oxygen, and my oxygen is going to equal red. So this is one way that a representation of a model of oxygen will look like. Okay? So let's look at another representation. Okay? Let's go for sodium. Okay? That's it. That's all there is to it, folks. Okay? Now, I know that my chlorine has to equal red because it's NaCl, and that means that my sodium must equal blue. 5-minute glitch again. My sodium is equal to blue. So this is my possibility of representing my chemical formula, my chemical compound, or my molecule of salt. Now, sometimes we draw these with sticks that represent bonds. And this is the way we would draw it. Okay? Now, the black line, all that black line is a chemical bond that is holding these two elements together, these two atoms together to make something new. Remember, sodium is a metal. It is a solid. Chlorine is a nonmetal. It is a gas. But when we put these two together, we get table salt. Amazing, isn't it? This is what is so cool about chemistry. So let's jump over to our PowerPoint. Let's talk about our PowerPoint a little bit. And I want you guys to make sure you have out a sheet of paper, something to take notes on. Okay? So let's talk about this. Chemical formulas. You need to write this down. Chemical formulas. This is going to be a vocabulary word for you. Use element symbols. Okay? Now, you do not have to write down from the periodic table. We know that. We know where they come from. I've taught you about that before. So they use element symbols. Okay? Now, they also use subscripts. Whoops. Subscripts were those numbers that we put down like this. This number, folks, is called a subscript. Now, let's think about this. The stem sub can mean below, and the stem script, meaning right. Whoops. Erase that real quick. Right. Did it to me again. So when we say subscript, when we're talking about something below the writing, okay, that's what this is. So what is the subscript number in H2O? The answer, of course, is 2. That's it. Okay? Let's see if we can figure out what a subscript is for something like this. Okay? Where are the subscript numbers? Well, this is a subscript number, this is a subscript number, and this is a subscript number. And all these subscript numbers tell us how many atoms of the certain element that they go with. Look, the element goes first, and then the subscript number goes second. So this is carbon is equal to 6. Does anybody remember what the H is? Hydrogen. This is really bad writing on my little piece of tech here. Hydrogen is equal to 12. And what do we have here? That's right. oxygen is equal to 6. So in this whole entire molecule of glucose, we have 6 atoms of carbon, 12 atoms of hydrogen, and 6 atoms of oxygen. That is incredible. So going back to our PowerPoint, there's that little 5-minute glitch. Going back to our PowerPoint, and let me pull up the laser pointer here. We know that the subscripts are right here, and here, and here, and here. But guess what? When we go to salt, where are the subscripts? That's right. There are no subscripts in salt. Why? Because it's already said, if there's no number there, it means there's only one. So that means there's one element of sodium and one atom of sodium and one atom of chlorine. And that's it. So chemical formulas use element symbols and subscripts to show the name and number of atoms of each element in the compound. Okay? Now, if you can't get all the notes while I'm talking, you can always pause the video and write this. Okay? So I'm going to move on to the next slide. All right. Now, we've already talked about this. You do not have to write down any of this. This is something we've already talked about. Now, if you feel like you need to write it down in order to help you remember, please do so. But I'm not telling you that you have to write this slide. So, in a chemical formula, which we've already seen, the numbers as subscripts show how many of each kind of atom are in the compound. The subscript is written to the lower right of the element symbol. If no subscript is written, only one atom of that element is part of the compound. Okay? All right, again, if you need to pause the video to get this down. Otherwise, I'm going to go ahead and move on. We talked about this again. Okay? For example, in H2O, now there's a problem on this screen, is what I did not do is I did not move this number down. Okay? I didn't do it for a lot of things. I got to do that real quick. Sorry about this. Hopefully by the next time I do this, I'll be a lot better at it and won't make so many mistakes. Alright. So, moving back to where, for example, the 2 right here, the 2 in H2O, the number 2 is the subscript for hydrogen and means there are 2 atoms of hydrogen in the compound of water. Okay? No subscript for oxygen. It's assumed to be 1 atom of oxygen. Now, I want you to write these down. N2, O2, F2, Cl2, Br2, I2, and H2. These are what we call diatomic molecules. Now, think about this. This word has a stem right here, okay? The first stem is Di. Whoops. Di. Right here, Di. Di, like in the word divide, which means to split in half or two, one of the other, okay? So 2, look, all of these have a 2. Atomic. Remember, we talk about atomic, we're talking about atoms, okay? Atomic, atoms. So, it says diatomic molecules where all of the atoms of the molecule are the same element. So, right here, N2 would be 2 atoms of nitrogen chemically combined. The same with O2, oxygen, F2, fluorine, Cl2, chlorine, bromine, iodine, and hydrogen. Now, here's the cool stuff about this. These are the way these exist in nature right now. They exist as diatomic molecules, which means if we were to look at these and kind of break them apart chemically, we would exist in nature as two atoms of hydrogen bonded together chemically. That's the way it exists. Same thing with nitrogen, oxygen, fluorine, chlorine, bromine, iodine. They exist as two put together. Now, these are gases. This is a gas. This is a gas. I want you guys to understand something. Fluorine is a gas. These gases exist in nature as this, and if you ever see N2, we are not talking about nitrogen that is so cold it's a solid, or to a certain temperature where it's a liquid. We are talking about nitrogen gas, N2. Okay? So, go back through the PowerPoint, or go back through the video. I'm going to go back through these again, just in case you need to pause on any of them. And, in fact, I'll take some of the, I'll take this off. You don't need that right there. You can go back through any of these, pause the video, and get whatever you need to get. Okay? Now, make sure that you fill out also the sheet that we did. And if you are able to take a picture of your notes that you did today and upload them to Google Classroom, that would be great. If you can't, don't worry about it. But like I said, make sure you do the sheet that is attached, and I'll check in with you guys another time. Look for a video. I don't know when we're going to have another video, but make sure that you look every day for Google Classroom. Hit me up if you need anything.